In Lesson 7.2, you will find the quotient of two monomials. You will also simplify expressions with negative and zero exponents. In our first example, we have r to the fifth divided by r squared. Well, r to the fifth is the same thing as r times r times r times r, and r squared is r times r. When you have a number over that same number, it has a value of 1, like 5 over 5 is 1, or 3 over 3 is 1. So r over r is also 1, and when you multiply by 1, it does not change anything. So I can cancel one r on the top with one r on the bottom, and then another r on the top with one r on the bottom, because those each have a value of 1, and when I multiply by 1, I will get what I started with. So this problem, when you simplify it, becomes r to the third power. In the second example, x to the fourth is x times x times x times x, and that's going to be over x. This time I can only cross out or cancel one x on the top with one x on the bottom, which leaves us with x to the third. Now, when you do not have an exponent on the variable, it's a 1. Now, what do you notice about what we started with and what our final answer was? That's right. You subtract the exponents. 5 minus 2 is 3, and 4 minus 1 is 3. Let's go ahead and start with our first example. Simplify. G to the third, h to the fifth over gh squared. You can think about this as two separate fractions multiplied together if you wanted. You could think of it as g to the third over g times h to the fifth over h squared. And when we simplify this part right here, g to the third over g, you would be able to cross out one g on the top with one g on the bottom, which would leave us with two g's on the top, or g squared. Or two g's multiplied together, I should say. Or you would use the rule and subtract the exponents. 3 minus 1 is 2. And then for the second part, we have h to the fifth over h squared. So we're going to be able to cross out two h's on top with two h's on the bottom, which is going to leave us three h's on the top being multiplied together. So that's going to be h to the third. Or using the rule, 5 minus 2 is 3, so it's going to be h to the third power. Remember, this rule only works when the base is the same. You may want to pause the video and try the next couple on your own. All right, if we look at the x's, we have 3 x's on the top being multiplied together and 2 on the bottom. So we can cross out 2 on the bottom with 2 on the top, which leaves us just 1 on the top. Or you would do 3 minus 2, which is 1, and we don't need to put the 1 there. We can just write x. And then y to the fourth over y. We can cross out 1y on the bottom with 1 on the top, which means we're going to have y to the third. Or we do 4 minus 1, which is 3, for our exponent on the y. Now for the next example, let's look at the k's. We can cross out 5 on the bottom and 5 on the top, leaving us 2 k's being multiplied together on the top. And then the m's, we can cross out 3 on the bottom with 3 on the top, meaning we'll have 7 m's still being multiplied together. And then 1p on the top can be crossed out with 1 on the bottom. That's just going to be 1, and when we multiply by 1, it doesn't change anything. So k squared m to the 7th is the simplified version of that. All right, next up, we are going to take a power of a quotient. 3p to the third over 7 to the second power means 3p to the third over 7 times 3p to the third over 7. And now you would rearrange and multiply the 3's together first. 3 times 3 is going to be 9. And p to the third times p to the third, think back to yesterday, 3p's being multiplied together and 3 more. You're going to add those exponents together. 3 plus 3 is 6, so 9p to the 6th power. And then on the bottom, in the denominator, 7 times 7 is 49. So you could work it out by writing out what it looks like. You know, since it's squared, you would multiply it by itself. Or you can think about what we talked about yesterday. This 2 needs to be applied to everything inside the parentheses. So the 3 is going to be squared. 3 squared is 9. The p to the third squared is a power to a power. We're going to go 3 times 2, which is 6. And then we're also going to take the 7 to the second power, which is 49. So there's a couple different ways you can think through that problem. You may want to pause the video and try the next one on your own. All right, you could write 3x to the fourth over 4 multiplied by itself 2 more times, or you can just raise everything inside the parentheses to the third power. 3 to the third power is going to be 3 times 3 times 3, which is 27. X to the fourth to the third power means x to the fourth times x to the fourth times x to the fourth, which is a total of 12 x's being multiplied together. So 27x to the 12th. And then in the denominator, 4 to the third power is 4 times 4 times 4, which is 64. And the last example like that, everything inside of here is to the second power. So 2 to the second power is 2 times 2 or 4. Y squared to the second power is y squared times y squared, which is a total of 4y's being multiplied together. And then on the bottom, 3 squared is 3 times 3, which is 9. And then z to the third squared means z to the third times z to the third, which is z to the 6th. Next up, we have the zero exponent property. Any non-zero number raised to the 0 power is equal to 1. For example, if you had 3 to the 5th power over 3 to the 5th power, anytime you have one number over itself, it's going to equal 1. So this is obviously equal to 1. Or if you use the rule, 5 minus 5 is 0. So 3 to the 0 power is going to equal 1. In example 3, this problem looks really complicated, but once I see that this entire quotient is being raised to the 0 power, I don't even need to do a thing other than say the answer is 1. Now in the second example like that, there is a little bit of thinking to do, but right here where I see y to the 0 power, that really is like having it be a 1. And when you multiply by 1, it's not going to change things. However, I can simplify the x to the 5th over x to the 3rd by subtracting the exponents. 5 minus 3 is 2. Or thinking about crossing out 3 x's on the bottom with 3 x's on the top, leaving it as x squared. Now the trickiest thing that we have left to talk about is negative exponents. Let's take a look at this right here. If I use my rule, I end up with c to the 2 minus 5 power, and 2 minus 5 is negative 3. Now if I go and think through what this means, like we did at the very beginning, c squared is c times c, and then on the bottom we have c times c times c times c times c. We'll be able to cross out two c's on top with two c's on the bottom, and these really are ones. So this is 1 times 1 in the numerator. 1 times 1 is 1. And on the bottom we have c times c times c, which is c to the third. These two things are equal. So c to the negative third power is going to be the same thing as 1 over c to the third. Basically, when you see a negative exponent, you're going to want to think reciprocal. Make it the reciprocal and get rid of the negative. So if you look down here, one example is 1 over j to the negative fourth power. Since we don't want negative exponents, we're going to write it as the reciprocal. The reciprocal would flip those around, and you end up with the j to the fourth power over 1, or just j to the fourth power. Or if it's 2 to the negative fourth power, that's 1 over 2 to the fourth power. Again, remember reciprocal when you see negative exponents. One way I like to think about it is if I see a negative exponent, I think about that being very unhappy or negative, and I need to move it to its happy place. So if it's upstairs, like it is here, we have to move it downstairs and make it positive. And if it's downstairs, we have to move it upstairs and make it positive. So if you look at this example right here, if I want to simplify it, which means I need to get rid of the negative exponents, and if we can simplify in any other way, we should do that as well. There aren't any other n's here, but this is negative, so I can't leave it there. I need to write that n part as the reciprocal. So instead of it being on the top, it's going to be on the bottom. Again, this is very negative or unhappy. We got to put it in its happy spot, which means switch it to the opposite side of the fraction bar. Now the p, there are no other p's to simplify that with, so I'm going to leave the p to the fourth right where it is, because it is happy with a positive 4. This r to the negative 2 power is unhappy where it's at. We need to put it to its happy place. We have to move it upstairs or do the reciprocal, which would put it from downstairs upstairs. So that r is going to come up here. So p to the fourth r squared over n to the fifth. This next one right here has quite a bit of simplifying to do. The first thing we're going to do is simplify the coefficients. The 5 and the negative 20 can be simplified because both of those numbers can be divided by 5. So I'm going to take this 5 and divide it by 5 and get 1, and the negative 20 divided by 5 is going to be negative 4. So I end up with, on the bottom, negative 4. I could put the 1 up here, but I'm going to have some other stuff there, and I won't really need to show multiplying by 1, so I'm going to just leave that off. Now move over to the r's. I have 2 r's on the bottom, but I have a negative 3 exponent here. It is not happy up there, so we need to move that down to its happy place. R minus 3, or r to the negative third power, we're going to move those 3 r's down here to join the 2 that are already there. So if I move 3 down to join those 2, it's going to be r to the fifth. Another way you could do that is with the rule. Negative 3, take away 2 is negative 5, and then since it's negative, we're going to write it down here and make it positive. Now with the t's, we have 4 t's up here and 7 down here. You could cross out 4 on top with 4 on the bottom, which would leave you 3 t's on the bottom being multiplied together. Or you use the rule. 4 minus 7 is negative 3, and since it's negative, we're going to put it on the bottom. And the last thing we have is the u's. And since they are not very happy here with this negative exponent, we're going to write that as the reciprocal by moving it upstairs and making it positive. So you could write your answer like this, or some might prefer to put the negative in the middle. Since this is positive and this is negative, positive divided by negative means it's going to be negative u to the fifth over negative 4r to the fifth t to the third. Now you may want to pause the video and try that last one on your own since these are a little bit tricky. I'm going to start out by simplifying the coefficients. The 2 and the 10 both can be divided by 2. 2 goes into 2 once, 2 goes into 10 5 times. So I'm going to have a 5 in the denominator, possibly a 1 up here, but let's just see if we even need to put it there. Now we have 2 a's here, and then we have a negative 3 here. These are not happy hanging out down here, so we need to send them upstairs to join the 2 that are already there, which is going to be a to the fifth power. Or if you use the rule, 2 minus a negative 3. 2 minus a negative 3 is a positive 5, and since it's positive, you would put it upstairs. Now move on to the b's. 3 up here, and this one is not happy here, so we're going to move him upstairs to join the 3 that are already there, which is going to make it b to the fourth. Or using the rule, 3 minus a negative 1 is 4, and since it's positive, it will go up here. Now on to the c's. These guys aren't happy, and these guys aren't happy. They both need to switch spots. These 5 need to move down, these 4 need to move up. And then when you cross out 4 on the top with 4 on the bottom, you're going to be left with just 1 on the bottom. Or you use the rule, negative 5 minus a negative 4. 5 minus negative 4, it's going to be a negative 1. And since it's negative 1, we're going to write it as a reciprocal and put it downstairs. Put it in the denominator. So it's going to be a to the fifth, b to the fourth over 5c.